everyone. Just waiting for a few people to come in. So obviously, well, or maybe not so, but biometrics is a huge part of phytotechnology across multiple modalities. We are extremely lucky at the Phyto Alliance to have Stephanie Schuckers, who is the director of the Center for Identification Technology Research, as the co-chair of our biometrics committee. And I would consider her the foremost expert in biometrics in general. So we're very lucky to have her here with us today to talk about bias in biometric recognition and the challenges and opportunities therein. Stephanie?
All right, thank you very much. Well, let's just get right into it. So bias, we were joking this morning about the B word. When we talk about bias related to biometrics, what we're really talking about is variability in performance due to demographics or demographic differentials. And of course, bias has a lot of other layered meanings in terms of who's implementing the system and what are their inherent biases. Those are important, not what I'm going to talk about today. We're going to talk more in the technology level. And is the technology or the AI or the thing underneath the hood operating in a way that has similar performance, depending on their demographic group? So why did this all come up? Well, it came up because it's important. Because when we did our work for the technology, we looked at performance, but we generally looked at aggregate performance. There was some work that split it up into the demographics, but not enough attention was paid. So one of the first papers that really shed a lot of light and got a lot of attention was called the Gender Shades paper. Very important work, led to essentially a whole kind of community working on this issue related to AI and bias. Unfortunately for biometrics, it was not about face recognition. It actually was about gender classification. And it's been mixed up in the media, in the press, as being related to being face recognition. That being said, it brought a lot of attention to the world. And as it turns out, in some of the testing, groundbreaking testing that NIST did, they did find variability in performance due to demographics. If you've read a NIST report, it's great reading, 150 pages of tables that look like this. But let me walk you through kind of one table, just to give you an idea. And I focused on this table in particular because I feel like this kind of thing is most related to what we think about within Phyto, because in Phyto, we're doing authentication. And I'll get into a little bit about what we need to worry about in terms of authentication as it relates to bias. But let's just talk about this. So this table I picked because it's the false non-match rate. So this is the false reject of the legitimate person. And I'm looking for the laser. All right. I can't do my whole graph setup. But if you look at the bottom axis, that's different countries of birth. And the y-axis is the error metric. A legitimate person is falsely rejected. And then the bars are the performance for each of those countries of birth. Left side's female, right side's male. Blue is above 45, red is below 45. So we're looking at here variations in performance due to demographics. That's what we're talking about here when we're talking about bias. And when we look at standards around this, we're calling that demographic differentials. So what is the goal then? The goal is no one group is adversely affected, i.e. their error is much, much larger. Their experience of the technology is much worse than another group. And so that, some of those bars that are quite much larger than the other bars, that's what we don't want. That's the goal. So how do we do this? And so I would keep on that and get into some of the details. What I do also want, I pulled a couple quotes here. False negative error rates vary strongly by algorithm. If you don't remember anything from my talk today, remember that bias relates to the technology, the specific technology, not the whole field of biometric recognition. And so they say that clearly in the NIST report. For the more accurate algorithms, false negative rates are usually low, with average demographic differentials being necessarily smaller still. This is out of the NIST report. So I'm going to get into a little bit about, well, what more can we do as a community to demonstrate that our technology minimize any variability in performance? So concerns around fairness, bias, demographic differentials depend on the type of implementation. I'm not going to go into every type of implementation. Luckily in FIDO, we have some very clear, specific use cases for where biometrics is used. One is for authentication. The second is the work going on in IDWG related to remote identity proofing. But just to give you an idea, so verification, we call that one-to-one matching. Am I who I say I am? Identification, is this person in the database? FIDO is not doing identification. We're talking about the left side here. The right side has a lot of very important use cases, many of them governments, some of them consumer-based. And this table is actually free for you to download off the Biometrics Institute website to help folks talk about different use cases and ways of implementing, because things like demographic differentials and many other aspects related to the technology vary depending on the use case. So please pass this on to folks who have questions. I'm not going to talk about all those details, but we'll move on from that. So if we're talking about verification within FIDO, we really want to focus on the top thing, what's called a false negative differential. Said simply, you're a legitimate person, you just want to authenticate, or you just want to get through that remote identity proofing step. Am I who I say I am? I don't want to be rejected, more so than my neighbor is rejected. Right? So verification is more important to consider the false negative differential, the genuine user's experience. That's not to say we need to completely, for verification, ignore false positives, but what false positives is a security risk for your organization. Say, for example, you have way more false positives for white, female, older than 45, like me, right? Then maybe there'll be a lot of white, older female attacking your system, right? So it is a security concern. In terms of bias, I think our sort of first steps should be to focus on our false negative differentials. Just to compare, one-to-N system, a false positive differential would be, I've been found in a database, right? But it's not really me. And so that would be ensuring the legitimate person is not falsely matched. So FIDO is really about the top. I think, and these are my opinions, where we should spend our time focusing for now. So we need to consider the impact of bias at multiple levels: the capture, the matching, and the database. So we, in CIDR, the research center that I work with, developed a set of educational videos around biometric technology. We realized there's a lot of confusion. What's verification? What's identification? What's false negatives? What's false positives? And so what's spoofing? How is my data secured? So we've created a set of videos, and we just finished, it's not even up on YouTube yet, a video related to bias. And so if I can take your time, I'm going to play that in the next slide, which happens to cover this particular thing, as well as just some general notions related to bias. And then I'll come back to share at least the YouTube channel that you can get access to these educational videos.
Mia, I'm Eric. Nice to meet you.
You too. So you want to learn more about access control systems?
Yes, I run a lab, and we need a better way to make sure that only the right people have access to the hazardous chemicals. We're thinking of using a biometric system, but I'm not sure which kind is best.
Well, there are trade-offs with every biometric system. Some don't work as well if you're wearing gloves, for example, or have eye damage or are wearing a mask. So it really depends on who's going to be using it.
I see. I've also read that some systems don't work equally well for everyone, especially facial ones. How would I make sure ours isn't biased?
So when it comes to bias, people often lump all facial analysis systems together: detection, recognition, and classification. While they are interrelated, they differ in how bias can occur and how often. You'd want a facial recognition system to make sure the person trying to access the chemicals is supposed to. Researchers have made a lot of progress on reducing error and bias in facial recognition, but there are still some technical things you should consider to make sure you're choosing a good system. The first one is image acquisition, or how it collects an image of someone's face. The important thing here is to have a high-quality camera. For example, it needs to adjust the lighting properly for people's skin tone to prevent bias. Next, there's the image gallery, which is the database of everyone in your lab that the image would be compared to. We can give you some tips on how to make sure everyone's headshot is high enough quality. And the final thing is the algorithm that's used for image matching. You need one that's been trained on a diverse enough set of people that it can tell everyone apart, even if they have similar demographics.
But how do I know if the algorithm is good enough?
You should make sure it's gone through independent testing. All our systems use algorithms that were tested by the National Institute of Standards and Technology, or the Department of Homeland Security, and had low error rates across all demographic groups. No system is perfect, but if you follow all these steps, you can make sure that yours works well for everyone in your lab.
Great, let me talk to my team, but I think we will go with one of your facial recognition systems.
Sounds like a plan.
So these educational videos, the one I just played for you is not yet up on the YouTube channel, but it will be up in the next few weeks. But we have 3 other videos up, and besides that one, we're launching 2 more. One of them mentions the Phyto Alliance, and so kind of ways biometrics can be used, to help with various applications. I think that's the 6th video. So stay tuned for that. Drop me a note if you want me to, or subscribe to the channel, or drop me a note if you want me to let you know when we add the next 3. It should be in the next few weeks. So getting into actually doing the testing and how to go about that. So as I mentioned and I featured some of the NIST results, the NIST results are available on the website. Not only the report that they did in 2019, but the ongoing testing that they're doing where you can look up vendor by vendor, not only their overall results, but their demographic results related. So FRVT stands for Face Recognition Vendor Test. But as we start to sort of mature what we're doing in terms of testing, we need to talk about the metric of which we would make a decision about whether we think a solution mitigates any kind of demographic variability. And so there is no ISO standard for this today. There is an ISO standard in a working draft format and being developed. And part of the conversations are around, how are we going to measure it? And then, some of the questions would be what would be requirements? What would be the methods to do the statistical analysis? So what I'm going to tell you is kind of my opinion on some ways forward that potentially even FIDO could get involved with, and I'll come back to that. So, what we want to see, not only do we have equitability, is that kind of those bars are all together when we look across demographics, that's number 2 there. But we also should ensure it works well, right? So we would like a solution that has some overall good performance. So I really think there's two criteria. One, you're under some threshold of performance, and that variability is minimized. And that's really what 1 and what should be number 2, the bottom and the top, are about. So what do I mean? So let's take it from the example of a graph. From this graph, we have 4 solutions. On the y-axis, we have some notional metric of performance. Let's say it's a false reject or a false negative. And then we have in this case, 4 groups. Say 4 race ethnicity groups or 4 age groups. And we're saying not only does it need to pass criteria 1, it needs to be below some threshold, say 10%, right? So that would be solution A and solution C passing, but also is it within some plus or minus, say plus or minus 2%. And then that would mean only solution A would pass because solution C, which passes the first criteria, doesn't pass the second criteria. So that's kind of the notional way of what we want to go, where we want to go to. The way to measure that variability can be done in a lot of different ways. But certainly we need to do statistical bounds, and I'll come to that in a minute here. And so one of the other lessons as we looked at methods to do what we call confidence intervals or statistical bounds is that the more groups you have, the more likely you might find a difference just by chance. And so any of you took a statistics class, you may remember type 1 and type 2 errors. Essentially, the idea is the more we look for differences, we're going to find something. Because anytime you cross-section a bunch of data and look at performance, you're going to see variability. So what we want to study or what we want to develop is these confidence intervals that allow us to say, what's the probability we would find a difference just by chance? That's what we want to measure. And that's what we're trying to do here. I know this is a lot to take in here, but let me just kind of walk you through it. The red dots are bad, right? The blue dots are good. Basically, if we look across G, which is groups or group 1, group 2, group 3, that may be age, it could be race, it could be gender, right? A bunch of groups, we're doing a bunch of checks. We want everything to be within some bounds or some confidence or some notion of confidence. If it jumps outside of it, then we can say that potentially that there's demographic differentials. So the question is, so M is that bound, that plus or minus. The question is, what should M be? How do we find what M is? Is it plus or minus 2%? Is it plus or minus 3%? Is it plus or minus 5%? Well, that's where the statistical analysis comes in. Because we say, what's the probability you might find that difference when there's truly not a difference? Right? And if we can get that probability, then we can say, really, there's only a 5% chance we may see a difference when there's not truly one there, or a 2% chance, right? And once we get that number nailed down, then we have an idea. When we do see something, we say it's only a 5% chance that it actually happened, or that it isn't a true differential, is essentially the idea. So this is some of the work we're doing. NIST is doing some great work. DHS is doing some great work on this area. We're all working towards ISO standards related to this kind of thing. And so here's just a quick graph to say, okay, as you increase the number of groups on your x-axis, that M, those bounds, gets bigger. Basically saying, if I keep looking and I keep looking, right, I'm more likely to find a difference by chance, and it's not a true difference. So we need to make our bounds bigger to ensure that doesn't happen. The dots related to N, just like what you learned in statistics, you make N bigger, you can make your bounds smaller. It's great, right? But can be very expensive from a point of view of the community and doing this kind of testing. Because I just plotted some ideas of what N could be, and this is the number of people per group you want to study. So if you've got 4 race, 2 genders, 4 ages, that's 10 groups right there, right? So your bounds are dependent on that. So if I say I have 10 groups and I want 50 people per group, then, that could be a lot of subjects depending on how you collect it. So this is some of the work we're doing, and I'm happy to say that we have been talking amongst FIDO. There's been a lot of discussion amongst the community about what could FIDO do in terms of testing to help with this issue. We already have a testing program for biometric components that go in authenticators. We are coming out with a testing program for remote identity proofing. And so between the two of these, is there a possibility to have a certification around bias? And so we're going to do an ad hoc group that wasn't even on your agenda, but I think has been added for those people who are attending the plenary. It will be Friday at 11:30. I think eventually it's going to be in the event app. It might already be there. So talk to me, talk to the FIDO staff to get you hooked up on that, and we're going to start a discussion on what we could do around this. So just to kind of wrap everything up, I think I've said it all already, and I see I'm out of time, so we can have time for questions.
Not really, but if you want, we would like to take some questions. Does anyone have a question for Stephanie?
I like questions.
No, I know we do. Come on. Well, I have good news for everyone. Yeah? Okay.
So in terms of just the sheer number of groups, I know NIST FERT has okay, sorry.
For people online, yeah, thank you.
I guess given I know that NIST FERT has a very large number of groups, but some other data sets have a much smaller number. Do you actually have a sense of based on your experience, where is that happy medium of where, if we were to nail down a number, what that should be?
Yeah, I mean, that simulation that I just showed you, we did a week ago, because I was saying, I just don't think, what I said in the May plenary for FIDO, when someone asked, could FIDO do testing? I said, well, we can't, we don't have enough subjects, we can't do it. And they're like, really, nothing you can do, right? So how many months have gone by since the May plenary? 4 months. So in that time, I've been doing a lot of talking, a lot of discussions, and I was talking to someone, and I said that exact same thing. I just don't think we have enough people. And they're like, are you sure? You don't have enough people? And I was like, well, actually, I didn't run it, the simulation. So that is the results from the simulation we ran, in the last week to see what it would take, to do so. So, I mean, it all depends on those two criteria, right? So, okay, what are you going to put your requirement to be? It must be under, and then that bound is then a function of that, as well as a function of the number of people and the function of number of attempts and a few other things. So that was a long answer to the short answer is I don't know. You're right. Okay. So maybe we can do it. It was promising to me when I looked at it. I was like, maybe we could do it, with the kind of testing we're FIDO's already doing today. Yeah.
I just had one question from the app for you, Stephanie, which is, are there biases to be aware of in voice biometrics?
Yes. In fact, our research center, and I forgot to thank the sponsors of the research center who, some of this research in bias as well as many other aspects related to identity and biometrics. We did have a paper come out related to voice biometrics and the variability in performance, right? And the minute you take any data set and you slice and dice it, you're going to see variability. The question is it meaningful? And of course, it's definitely algorithm dependent.
Yeah, I have a question.
Yes.
That's along the lines of the question I have, which is multimodal biometric collections. Is that beneficial, or is the standard technology not there yet to implement these systems?
Where is multimodal in terms of bias? Is that, or just generally multimodal?
Using, for example, voice, facial,
Yeah, so multimodal biometrics has a lot of properties that could be beneficial, but it's all depends on exactly how you're implementing the multimodal biometrics, because there are ways you can implement it that definitely will help mitigate some of your problems, but also may introduce new ones like friction, to your user. And so I can't really answer the question because the way you can put multimodal solutions together depends. You can put it like, I must have all of this information before I can make a decision, or you could treat it like a step up, or I'm going to start here. If I'm not sure, I'm going to add that, right? Or it could be a fusion of scores. There's a lot of, and I'm missing a score, so there's a lot of ways to do multimodal biometrics. Within FIDO, it is possible to do testing in the biometric component testing with a multimodal system, and we have spelled out the way you would do testing. And I don't want to get into the nitty-gritty details because I can see it flashing here, but I'm happy to chat more. And so, yeah, it's basically fusion dependent. But yeah, great question. Thank you.
Thank you, Stephanie. And the good news is Stephanie is actually part of the next session as well, which we will start in about 3 minutes. So please join me in thanking Stephanie for this excellent presentation on bias.